So the question is, if x is equal to a into e to the t sine t, y is equal to a into e to the t cos t, find the derivative of the arc length, that is ds by dt, and find the angle psi. Okay, fine. So we'll start with the x which is given here, that is a into e to the t into sine t. So what I basically need is dx by dt. So differentiate this function with respect to time. Okay, so when we do this dx by dt, right, a is a constant, we'll write a outside, then see that there is a product, e to the t into sine t. So when we have that, we can use the product rule, keep the first function as it is, differentiate sine t, and you get cos t. Okay, plus differentiation of e to the t is e to the t into second function as it is, that is sine t. Alright, now I can see that the e to the t is constant, is a common thing, so I'll take it out, e to the t, a into e to the t, so this becomes cos t plus sine t. This is dx by dt. Okay, very similar to this. Now I need to find the dy by dt as well, so we'll start with y is equal to a into e to the t into cos t. So anyway, I'll call dx by dt as equation 1. So perform dy by dt. So dy by dt is nothing but a is a constant, we'll keep it out, right? This is e to the t, first function as it is, differentiation of cos t is minus sine t, plus e to the t differentiation is e to the t, and second function as it is, which is cos t. So I can write this in this format, that is dy by dt is equal to a into e to the t. I'll write the positive term first, so cos is positive and sine is negative, so call this as equation number 2. So now if you see, this is a parametric format, this is not a straightforward way, this is type 2. So in case of type 2, how do you write? This can be written in the ds by dt is equal to square root of, this is dx by dt the whole square plus the dy by dt the whole square. Okay, so this is nothing but, now I can see that dx by dt is equation number 1, dy by dt is equation number 2, which we already have got. I'll substitute in this way. I need to square it before I put this inside this bracket. So there is a into e to the t I had, squaring that you get a square, e to the t becomes e to the 2t, into the first term is cos t plus sine t the whole square. This is the squaring of dx by dt plus, now we know that I should write dy by dt. dy by dt has a becomes a square. Then I had e to the t, which becomes e to the 2t, into, see, this is cos the t minus sine t the whole square. Okay, now so let us try to simplify this further. So in both of these terms I have a square common. When you take it out, it becomes a. E to the 2t is also common, it becomes e to the t out of the square root. Okay, then I write square root of, now this is nothing but cos square of t plus sine square of t plus 2 times sine t into cos t, that is expansion of this term, cos t plus sine t the whole square. Alright, then plus in the second term you can see that a square e to the 2t has already gone out. I still have left with, this is cos square t, cos of t whole square, plus sine t that becomes sine square t, and once again under the square root only I have the next term coming up, that is minus 2 times sine t into cos t. This is still under the square root. Okay, now you see that these two terms will get cancelled because this is still under the square root. Okay, so I can just show that it's still under the square root. Okay, fine. Now I can see that cos square t plus sin square t is this. This is what? This is 1. What is the second term? That's also 1. So 1 plus 1 is 2. So my answer is nothing but, that is ds by dt is a into e to the t into square root of 2. Okay, that is ds by dt. First part of the answer, that is over. Now let's go to the second part of the answer. So in the second part our intention is to calculate the value of psi, but I will start with the tan psi. We know that the tan of this angle psi is nothing but, what is that? That is dy by dx. But in this particular problem I don't have a dy by dx directly available. Okay, so what you do, you can simply write dy by dt whole divided by, this is my numerator, divided by the dx by dt. If you do such thing, I know that dt cancels and I get dy by dx. Okay, anyway, just to substitute that, let's write the dy by dt in the numerator. That is a into e to the t into, this is cos t minus sin t whole divided by, this is a into e to the t cos t plus sin t. Okay, so it's very clear that a e to the t, a e to the t will cancel. Okay, after that I'm left with cos t minus sin t and cos t plus sin t, out of which let me take the cos outside. Right, so we have substituted the dy by dt whole divided by dx by dt. So it's clear that e to the t is common in both the case, and I'll write it in this way. So that makes, we are left with just cos t minus sin t, and in the denominator we are left with cos t plus sin. What I do, I try to cancel few more terms. So I'll take the cos t outside. So this becomes, cos t has gone out. When you take the cos t out from the second term, you have to divide that by cos t. This is the numerator whole divided by denominator. Also I try to take the cos t outside. So this becomes 1 plus sin t divided by cos t. Okay, so once again it's very clear that I am cancelling the cos t in both the cases. So this is left out with sin by cos is a tan function. So this is tan t divided by, this is 1 plus tan t. Okay, so now we have one very important relationship that we can write directly from the basics of trigonometry. That is, if you have something like 1 minus tan theta whole divided by, this is 1 plus tan theta, this can be written as tan of pi by 4 minus theta. Okay, this is the very standard relationship that we have in the trigonometry. Okay, so because of that, now what I'm trying to do here is I'll use this equation in the above case. So this means on the left hand side I still have the tan psi is equal to this whole term 1 minus tan t by 1 plus tan t, I can write simply as tan of pi by 4 minus t. Okay, so tan I can cancel and I can write psi is equal to pi by 4 minus t is the final required answer. Now we'll go to the next question. This is the next question. If x is equal to, this is a into theta minus sine theta, and say y is equal to a into, this is 1 minus cos theta, then find psi ds by dx and ds by dy. ds by dx and ds by dy. Okay, so let's start with the given data. X is given as a into, this is theta minus sine theta. So when this is given, I can directly find the dx by d theta. Okay, so this means a is a constant. When you have a outside, differentiation of theta is 1 minus sine theta differentiation will be cos theta. Okay, we got dx by d theta. Similarly, let's start with the given data of y. Y is equal to a into 1 minus cos theta, right? So this means dy by d theta is equal to, differentiate that with respect to theta, a is a constant, so into 1, differentiation of 1 is 0, minus cos theta, differentiation is plus sine theta, right? So we got dx by d theta and dy by d theta, so we can directly find out the tan psi initial. Okay, so tan psi is equal to, tan psi is nothing but dy by dx. But anyway, this is not a direct form, this is a parametric form. So whenever we have the data present in the parametric form, what you are going to do, you will write it in this notation. Okay, that is dy by d theta whole divided by the dx by d theta. So let us substitute. So tan psi is nothing but, what is dy by d theta? That's a sine theta whole divided by, what is dx by d theta? If you see, this is a into 1 minus cos theta. So anyway, a and a is cancelled. So whenever I have sine theta by 1 minus cos theta, we always represent the sine and cos using the half angle formula. So sine theta is nothing but 2 sine of theta by 2 into cos of theta by 2, half angle formula for sine function. Similarly, half angle formula for 1 minus cos theta is nothing but 2 into, this is sine square of theta by 2. So what we know, we can actually cancel one of the sine function with one of the sine in the denominator, right? And also the 2 and 2 will get cancelled. So because of this, I'm left out with what? On the left hand side, I still have tan psi, that is equal to, this is tan, is it tan? Oh, sorry, cos by sine, right? So it is not tan, it is cot. This is cot of theta by 2. So you know that both sides are positive, it indicates that it is in the first quadrant. So first quadrant means pi by 2 minus that angle. So I can write this as, this implies tan psi is nothing but, if you want to convert this into tan, it's fine, but it should be in the first quadrant. So pi by 2 minus that angle is theta by 2. Alright, so this implies the psi can be written as pi by 2 minus theta by 2. So this is the answer to the first question which they have asked. Alright, then proceeding further, I need to calculate ds by dx in the next part. So what is ds by dx? ds by dx is nothing but, as per the equation, this is square root of 1 plus dy by dx the whole square. Okay, so if I go back and check what is dy by dx, you can see that what is dy by dx? dy by dx is cot of theta by 2. Okay, so I can simply write this as, this is equal to square root of, this is 1 plus dy by dx is cot theta, so this is cot square of theta by 2. But I know something from the basics, 1 plus cot square theta is cosecant square of that angle, so theta by 2 will remain theta by 2, so that is equal to root and square will cancel, you are left with simply cosecant theta by 2. This is the answer for ds by dx. Okay, similar to this I need the next answer, that is ds by dy. Right, so if you want to calculate ds divided by dy, the equation will slightly get modified as 1 plus, this is dx by dy the whole square. Okay, so I know that if I want to calculate, I know the dy by dx. So if you want to calculate the dx by dy, right, it's 1 by the term, so 1 by that means it is tan theta, so you can simply write this as root of 1 plus dy by dx is cos, sorry, not cos, cot, cotangent, 1 by that will give you dx by dy, which is 1 by cot theta, which is tan theta, so this is tan square, angle is theta by 2. Alright, so this means 1 plus tan square theta is nothing but, what is that? That is a secant square theta by 2. So square root and square will cancel, you get secant of theta by 2 as the final answer. Okay, yeah, so this is the standard answer. Let's go for the next question. This is, if x is equal to a into, this is theta plus sine theta, and y is equal to a into 1 minus cos theta. Okay, then show that ds by d theta is equal to 2a cos theta by 2. Okay, this is the question. So the answer is always, you will start with this way. So I need to find the dx by d theta first. Okay, so you can see that x is a function of theta, y is also a function of theta, so this is type 2. Type 2 means it is parametric form. Okay, so you always start in this fashion, find dx by d theta. So in the given x equation, a is a constant, keep it out, then differentiate. So theta is 1, differentiation of sine theta is cos theta. Okay, that is dx by d theta. Similarly, we need dy by d theta. So dy by d theta, a is constant into differentiation of 1 is 0, then I have minus cos theta whose differentiation will be sine theta. Okay, so we got dx by d theta, dy by d theta. Why did you calculate dx by d theta and dy by d theta? Because in order to get the final answer, that is ds by d theta, right? Derivative of the arc length. You need this. This is equal to dx by d theta the whole square plus dy by d theta. This is also squared. Okay, just now if you see above, we have the dx by d theta with us, also dy by d theta with us. Correct. So this means you can simply write this is equal to, substitute from the above answer. This is square root of dx by d theta is a into 1 plus cos theta, square it. So this is a square into 1 plus cos theta the whole square, plus, see the dy by d theta should be substituted. This is once again a square into sine square of theta. Alright, now I can see that in both the terms a square is common. You can take it out of that and take it out of the square root. A square, when it comes out, it simply becomes a. Alright, into square root of, expand the terms. 1 plus cos theta is 1 plus cos square theta plus 2 into 1 into cos theta plus this is sine square theta. Okay, so this cos square theta plus sine square theta is nothing but 1. So there is already a 1 present inside the square root. So 1 plus 1 becomes equal to 2. So my term is, this is root of 2 plus 2 cos theta, right? I can see a 2 cos theta inside the square root. I'm writing that as it is. Other terms I'm clubbing them to get 2. 1 plus cos square theta plus sine square theta is nothing but 2. Now I understand that the 2 is a common thing over there. So this is a into root of 2 into 1 plus cos theta. Okay, so now we use a trigonometric identity, that is 1 plus cos theta is equal to 2 cos square theta by 2. Okay, so this is the standard trigonometric identity that I'm going to use now. Right, so that means this becomes equal to now a into root of 2 is already present into 1 plus cos theta is nothing but 2 times cos square, 2 cos square theta by 2. So now you can see that this is a into square root of 4 cos square theta by 2. So 4 is a proper square, so root of 4 is nothing but 2. So I'll write in this way, this is 2 into cos theta by 2. So if you go back and check the answer, they are asking us to prove the same thing. Show that ds by d theta is 2a cos theta by 2. Okay, you can see that that's already here. So this is equal to 2a cos theta by 2, which is nothing but the required ds by d theta. Okay, this is the final answer. All right. Next question. This is if r is equal to, this is a into 1 minus cos theta, right? You then find ds by d theta and ds by dr. So now you can see that this given question is polar form. It's not the x and y, it's not just x and y, it's not x t and y or x theta and y, it's a different format. By just looking at this, we should be able to understand that the given question is polar format. So whenever it is polar, right, we don't have the x and y coming up, you have r and theta. So you can see that the given function is in terms of r and theta. So we have to find out ds by d theta and ds by dr. Okay, so what we do, we always try to find out the dr by d theta first. Okay, so first find dr by d theta is equal to, anyway, a is a constant, differentiation of 1 is 0, minus cos theta, differentiation is sin theta, so a sin theta. When you have this, we know that we have two standard formulae available for us. That is, if you want to find ds by d theta, this can be calculated as square root of r square plus, this is dr by d theta, the whole square. So already we have written this equation, right? So simply we are using it now. Okay, so this is equal to, I just look what is the given r value. From the given equation, r is nothing but a into 1 minus cos theta. So I need r square. So this is a square into 1 minus the cos theta whole square plus, see, dr by d theta is just calculated, which is nothing but this is a square sine square theta. Okay, now I can see that the a can be taken out. A square is common in both of them, so I'll take a outside the square root. A square, when it goes out, it becomes a into 1 minus cos theta, expand. So this is 1 plus cos square theta minus, this is 2 cos theta plus sine square theta. Right, I can see that a into square root of, there is cos square theta plus sine square theta, that is 1 plus, there is already a existing 1 there, so this becomes 2, so 2 minus 2 cos theta. So this can be written as a into square root of, this is 2 into 1 minus cos theta. So let's use a trigonometric identity, that is 1 minus cos theta is equal to 2 times sine square of theta by 2. Right, previous problem we used 1 plus cos theta, that is 2 into cos square theta by 2. Okay, all right, now simplifying this, this is equal to a into square root of, there is already a 2 present, into 1 minus cos theta is 2 times, this is sine square of theta by 2. So 2 into 2 is 4, under root of 4 becomes 2, into sine square theta is sine of theta by 2. Okay, so that means if you want to calculate ds by d theta, that is 2 a sine theta by 2. This is the required answer, okay, of the first part of the question. Then you see that there is another part of the question that says calculate ds by dr. Okay, so that is ds by dr. The standard equation is 1 plus r square into d theta by dr the whole square. So now we need to substitute all these values from the given data. That is equal to square root of, this is 1 plus r square, right? What is r square? R square is a square into 1 minus cos theta the whole square. This is r square into, see, dr by d theta, I know when you want to calculate d theta by dr, it goes to the denominator. So how you write that? That is a square into sine square theta. Okay, now so let's simplify this further. So let me write it in this fashion. This is 1 plus, anyway, the a square gets cancelled, so this is 1 plus, not plus, 1 minus, sorry, this is 1 minus cos theta the whole square divided by this is sine square theta, everything under the square root. Alright, so now this is nothing but take a common denominator, so that means this is sine square theta plus 1 minus cos theta the whole square whole divided by this is sine square theta under root. Alright, so in the next step we'll substitute like this. So this is equal to, see, the sine square theta in the denominator can come out as simply sine theta, because sine square theta under square root and the square will cancel, you have sine theta, but since it is in the denominator I'm going to write as 1 by sine theta. Okay, multiplied by, let's expand, so this is sine square theta plus 1 plus cos square theta minus 2 into cos theta. So cos square plus sine square is 1, so 1 plus the other one which is present inside this bracket is going to give me a 2 over there. So this is sine theta into square root of 1 plus 1 is 2 minus 2 into cos theta. So already we have solved this square root term, so let's quickly write the same thing here. This is sine theta into square root of this is 2 into 1 minus cos theta. So I know that 1 minus cos theta is equal to 2 times sine square theta by 2 from the basics of trigonometry. So this means I can simply write this as this is equal to 1 by sine theta, multiply that with root of 2 into 2 into 1 minus cos theta is sine square of theta by 2. So this is equal to 1 by sine theta into, so this is 2 sine theta by 2. So now what I do, I try to write the denominator sine theta in the half angle format. So numerator is 2 times sine theta by 2 divided by sine theta is nothing but 2 sine theta by 2 into cos theta by 2, half angle formula for sine. You can see that 2 cancels, sine theta by 2 sine theta by 2 cancels. So this is 1 by cos, right? 1 by cos is nothing but secant. So this is secant of theta by 2, which is the required answer for ds by dr. Okay, so this is the answer. Then let's go to the next question. Okay, this is the next question. If square root of r by a is equal to secant of theta by 2, then find the values of ds by d theta and ds by dr. Alright, what we do, we first try to square the given data. So given data is square root of r by a is equal to secant of theta by 2. So squaring gives you r by a is equal to secant square theta by 2. Okay, now what you do, you write r is equal to a into secant square theta by 2. Okay, this is what we get now. Now since the given this particular curve r is equal to a into secant square of theta by 2 is a polar curve, I should follow the rules of polar. So what I want dr by d theta. Okay, so differentiate this given function with respect to theta. So dr by d theta is equal to A is a constant into secant square is 2 into secant theta by 2 into differentiation of secant theta is nothing but this is secant theta by 2 into tan theta by 2. Okay, into the differentiation of theta by 2 is half. See, we are applying the chain rule. Okay, so what happens? This is nothing but uh, you have 2 and half will get cancelled. So this is equal to a into secant square theta by 2. There are two secant terms into one tan term. So that is tan of theta by 2. So this is what? This is dr by d theta. Okay, but I know that what is this secant a secant square theta. If you see a secant square theta, I can simply replace it as r. Correct. So I'm going to rewrite this in the following format. So this is equal to a secant square is r into tan of theta by 2. So you see that dr by d theta is this. Okay, now therefore write the equation for ds by d theta. ds by d theta is equal to, we know that very standard equation, this is equal to r square plus dr by d theta the whole square. Right, I know this is the standard equation, so I'll substitute. So this is r square plus, what is dr by d theta? That is r tan of theta by 2 the whole square. Correct. So this is equal to square root of, I have r square plus r square tan square theta by 2. So r and r common in both of them, I'll take it out as r. This is 1 plus tan square of theta by 2. Okay, I know that 1 plus tan square theta is nothing but secant square of theta. So that is equal to r into square root of, this is secant square. Now it's not theta, it's theta by 2. So square and square root will cancel. So you are left with r into secant theta by 2 is the required answer for ds by d theta. Okay, this is the first half of the question. And moving on to the second half of the question, that is ds by dr. So if you remember, the equation for this is going to be 1 plus r square into, this is d theta by dr whole square. Okay, so this is equal to under root 1 plus r square into, so dr by d theta is r tan theta by 2, but d theta by dr should be 1 by that. So 1 divided by, this is r square into, this is tan square theta by 2. So you can simply cancel them. R square cancels. Then 1 by tan square will be cot square. So this is equal to, so under root 1 plus 1 by tan is cot, so you have to write cot square of theta by 2. So once again, using the basic properties of trigonometry, I can write this as square root of, what is 1 plus cot square theta? If you remember, that is cosecant square of theta by 2. So root and square will cancel. So the answer is cosecant of theta by 2, which is the required answer for ds by dr. Okay, right. Then let's go to the next question. Okay, this is if r is equal to a divided by theta, right? Then show that ds by dr is equal to root of r square plus a square whole divided by r.